Hello to everyone. This is Shantan Kumar, Assistant Professor, Department of Mathematics, Institute of Aeronautical Engineering College, Dundigal, Hyderabad. The subject is matrices and calculus. Today, we are going to discuss the topic on the mean value theorem. Here, the mean value theorems are the three theorems. One is a Rolle's theorem, second one is a Lagrange theorem, and third one is a Cauchy's mean value theorem. That means we are going to discuss regarding the particularly the mean value theorems. These are the three theorems in the sessions we are going to discuss. First of all, out of the three theorems, we need to discuss that first theorem, that is under the mean value theorem, Rolle's theorem. What are the conditions for the Rolle's theorem? When it is satisfied the Rolle theorem, that means depend upon the function is a continuous function and again the differentiable function and based upon the related the conditions under the Rolle's theorem. First, we need to discuss for the Rolle's theorem, what are the conditions for the required to satisfy the Rolle's theorem. For example, the Rolle's theorem. Here, let us consider f of x be any function such that here the three conditions are required majorly. One is it is a continuous function in the closed interval a comma b, and second one it is a differentiable open interval a comma b, and f of a is equal to f of b. And again, then there exists at least one point c in open interval a comma b such that here f dash of c is equal to 0. These are the three conditions are required to satisfy. Then only the Rolle's theorem it will be applicable. If any one of the condition is not satisfied, then the Rolle's theorem it is does not exist. That means when we are going to satisfy that Rolle's theorem, that means here the three conditions are required to satisfy, and based upon the three conditions are satisfied, then we need to find out with the help of the f dash of c is equal to 0, then there exists c belongs to a comma b is satisfied. That is the meaning of the Rolle's theorem. That means here we need to remember one is a continuous function in the closed interval a comma b and the differentiable in the open interval a comma b. F of a is equal to f of b. Then there exists. That means based upon the three conditions are satisfied, then only you need to further it is then there exists c belongs to a comma b such that that is f dash of c is equal to 0. And these are the three conditions to satisfy and again find the solutions. Here, what is the geometrically interpretation of the Rolle's theorem? That also we need to understand. Geometrically how to define the Rolle's theorem, it is applicable. That means based upon what we discussed in the previous slide and based upon that we need to geometrically how to describe about the Rolle's theorem, that is the conditions. For example, here if f is a function a comma b to real number b is function satisfied the three conditions are of the Rolle's theorem, then the graph we need to observe this is the graph, and based upon this graph here according to the first condition y is the given curve. That means according to it is a curve is according to it is a parabola y is equal to f of x. For example, it is assumed that, and again here also we need to assume this is also the parabola. That is one of the any curve, not at a particularly like the parabola, but we need to assume one of the curve, that is y is equal to f of x, is a continuous. And what is the meaning of this continuous? The continuous is nothing but without any break. That means without any disturbances. For example, the curve is passing, for example, from here to here, and again the continuation at the point, for example, this one like this. Means this is not a continuous function. That means here some disturbances will be occur. This is the meaning of it is not a continuous. That means any function is given, it is without any gap or without any break. It should be continuous without any disturbances. That is the meaning of continuous. That is under the interval, that is a comma b. That is a closed interval. It is a point and it is a b is the point. That is the meaning of y is equal to f of x is a continuous in the curve in the closed interval a comma b. And we need to understand what is the meaning of the closed interval, what is the meaning of sometimes it is open interval. The closed interval is nothing but, for example, if it is a consider 2 comma 3 is any closed interval, or for example it is a 2 comma something like that, it is a 8 for example. And this is the meaning of closed. Means what is the meaning of this one here? Including the point that is a 2, and again including the point of that is also 8. That means from starting to 8, that is a 2 comma 3 comma 4 comma 5 comma 6 comma 7. That means including that starting and ending, and including the between the values, that is the meaning of the closed meaning. And the meaning of, for example, 2 comma 8 is open interval. The open interval is nothing but it is not including the 2 comma 8. That means other than the 2 comma 8 is nothing but 3, 4 and 5, 6, 7. This is the meaning of the open interval. Sometimes off intervals. What is the meaning of that off interval? For example, actually here it is not raising, but we need to understand what is the off interval. The off interval is nothing but it is a, like one side is a open and other one is a closed. For example, 2 comma 8. This is the meaning of indirectly it is off interval. And the meaning of this one, not including the 2, but including the 8. That means that is a 3 comma 4 comma 5 comma 6 comma 7 comma 8. This is the generally mean we need to understand. That is a closed interval, and again the open interval is, and again the off interval. But here, as per the statement of this is the like Rolle's theorem, here a comma b is a closed interval. A comma b is a closed interval is nothing but including the points of a comma b, that is a continuous function, it is a satisfied. The y is a curve, it is satisfied in the closed interval a comma b. And similarly, here the second condition, then there exists a unique tangent at a line at every point x equal c, wherever the point is a is less than c is less than b. This is the meaning of not a closed interval, that indirectly it is a consider it is open interval, because of that one of the point is something in between a comma b. That is the meaning of it is not mentioned that is equal to, it is given that only less than. That means it is a open interval. That means it is a tangent is nothing but automatically it is the differentiable, it is existed, and based upon that it is a differentiable in the open interval a comma b is the point. And based upon this one, the ordinates of f of a comma f of b at the end points a comma b are equal, so that the points a and b are equidistant from the x-axis. That means f of a, whatever it is a, and again with the help of this, there is a f of a, and again whatever it is a b, that is f of b, then it is a condition is nothing but f of a, that particular point is equal to f of b, is nothing but whatever from the distance here to here, it is f of a and f of b, it is both are the same. From that, according to f of a is equal to f of b. That means the conclusion of this one, it is f of x is a, y is a curve, it is a continuous function in the closed interval, and it is a differentiable in the open interval a comma b, and f of a is equal to f of b is the three conditions are it is required to satisfied. And based upon this, then there exists c belongs to a comma b, such that we need to find out what is the f dash of c is equal to 0. This is the, in geometrically we can derive according to or define or describe, that is the Rolle's theorem of the condition. For example, with the help of the problem, then how to describe that Rolle's theorem it is existed or not conditions. For example, we need to discuss one problem. Verify the Rolle's theorem for the function f of x is equal to 8x cube minus 6x square minus 2x plus 1 in the interval 0, 1. That means what we are going to observe here, the function is clearly mentioned 8x cube minus 6x square minus 2x plus 1. The limits are given that is a closed interval 0, 1. That means we need to understand here the closed interval is nothing but it is including a 0 and also 1 and in between the values. And in between the values that 0, 1 is nothing but from starting that 0 0.1, 0 0.2, 0 0.3, 0 0.4 up to that is a 0 0.9, including the 1 is also it is a maybe the given points. That means with the help of the Rolle's theorem, whatever we understood that previous slide, the conditions. What are the conditions here? First we need to recall or remember based upon that f is a continuous. And is it problem the function is a continuous? Okay, it is a continuous function because of here the function is a polynomial function. According to as we know that in generally every polynomial function is a continuous function, that is based upon the property of the polynomial function. And as per that the property, it is a polynomial function, therefore every polynomial function is also the continuous function in the interval of that a comma b. But here the interval of closed interval is a 0 comma 1. Therefore, we need to mention that since the polynomial continuous function is in that 0 comma 1 is a closed interval, therefore f of x is a continuous function in the closed interval 0 comma 1. And similarly, and again that f of x is a derivable. That means it is a derivable means that is a derivative, is it existed or not? That means we need to understand the here the function is 8x cube minus 6x square minus 2x plus 1. It is a derivative. The derivative is nothing but it is a 24x square minus 12x and again minus 2 is the derivative. And it is also the derivative is also nothing but it is a polynomial function in that prescribed that interval 0 comma 1. Therefore, it is a derivative is existed, and again moreover in the open interval this is also function is a derivable is a satisfied. Therefore, that since f of 8x cube minus 6x square minus 2x plus 1 be derivable based upon this one in the open interval 0 comma 1, then f is also the derivable in the 0 comma 1. And see, we need to understand here in other terminology, here easy to understand the continuous. That means whatever the points, it is 0 comma 1. For example, f of x is the given function at f of 0. In other terminology, we need to understand here when we are going to replace in the given function at x is equal to 0, the function is automatically something the finite value. The finite value, for example. Why? Because 8 into 0 is nothing but 0, minus 6 into 0 is nothing but 0, minus 2 into 0 is nothing but 0, plus 1. That means the value is 1. The 1 is nothing but it is a value is a finite value. Therefore, the function is at x is equal to 0, it is a finite value is nothing but indirectly in other terminology continuous function. And again, for example, f of 1 value. That f of 1 value means at x is equal to something 1, the value is 8 minus 6 minus 2 plus 1. Here is also the value is nothing but whatever the values. It is not required that a particular value. It is something value. It is not infinity. Therefore, it is a finite value. That indirectly the function is a continuous function. That we need to understand. And what is the meaning of the other than the continuous means? When we are going to replace that particular x is equal to 0 or 1, if we get any something infinity terminology, that means it is a discontinuous function. But it is clearly the function is a finite value, nothing but it is a continuous function. That is also in other terminology to understanding level of the function is a continuous function. And again the derivable, for example. And the derivable is nothing but the function is a like f of x is equal, that is a function is given that 8x cube like that, and f dash of x is nothing but you obtain this one. For example, here also in the open interval x is equal to 0 comma 1, and by taking any value of in between 0 comma 1, after getting the derivative, if you are going to replace that particular value, it is also not an infinite value. That means after replacing in between that 0 comma 1 any value, in that replacement of f dash of x, the value it will be not a satisfied any infinity. That means here also it is a finite value. Therefore, the function is a derivative is existed and in the interval 0 comma 1, that is a open interval. And these are some clarification to understand whenever the function is a continuous and also the function is a derivable, how to verify. That is ourself, it is understanding purpose. And again, third one, that f of a is equal to f of b. That means f of a, that in that given the function at x is equal to 0, the value is automatically 1, and x is equal to 1, that is according to f of b, and b is nothing but 1, that f of 1 is also 1. While we are going to observe here that f of a is equal to f of b. That means f of a is equal to f of b means according to the three conditions are it is existed. Therefore, the function is satisfied the Rolle's theorem. And if it is satisfied all the three conditions, and further based upon the Rolle's theorem, we need to find out such that f dash of c is equal to 0, then there exists c belongs to a comma b, and f dash of c is equal to 0. And meaning of f dash of c means, as we know that f dash of x, then we need to find out what is a f dash of x first. Therefore, f dash of x is nothing but that is a 24x square minus 12x minus 2, and this is the f dash of x. But we required f dash of c is the required. Therefore, f dash of c is nothing but replacement x is equal to c, that is f dash of c is equal to that is 24c square minus 12c minus 2 is equal to 0. And from these equations, we need to find out what is the C value. Therefore, by solving this C value, we obtain that clearly 3 plus or minus root of 21 by 12 is the value. Because of the quadratic equation we obtain, therefore C is equal to, we obtain the two roots. Therefore, here the roots are 3 plus root 21 by 12 and 3 minus root 21 by 12. And here, one of the root is, it is a, with the help of the plus, the value is a plus 0.63, and again if it is a like minus, that 3 minus root 21 by 12, the value is a minus 0.132 is the value. Now we need to understand, as per the Rolle's theorem, if the three conditions are satisfied, then there exists C belongs to A comma B such that it is satisfied. C belongs to A comma B. And C, what is the belongs to A comma B? The given interval is 0 comma 1. And while we are going to observe here, in between that 0 comma 1, and which one it is satisfied? That is a 0.63 is a satisfied. Because of under the 0 comma 1, it is a negative is a not required. Therefore, then there exists C belongs to A comma B, at least one point should be satisfied in the given interval. Here, out of the two values, it is satisfied. One of the value it is existed. The value is 0.63. Therefore, hence only the value C is equal to 0.63 lies in between 0 comma 1. Therefore, here the three conditions are satisfied. That is, one is a continuous function, and again the differentiable function, and again f of A is equal to f of B, and again here f dash of C is equal to, that is a C belongs to A comma B, that is also satisfied the condition. If all the conditions are satisfied means hence the Rolle's theorem it is verified the conditions. Like this, any problem is given, we need to verify further based upon these are the clarification. One is a continuous in the closed interval, and the derivable open interval, and f of A is equal to f of B is a condition. And based upon that, f dash of C is equal to 0, then there is to C belongs to A comma B is the condition is satisfied. And for example, here verify the Rolle's theorem for the function. Here f of x is equal to sin x by e power x. Here, while we are going to observe here, sin x by e power x is nothing but e power minus x into sin x. Both are the same. In the interval 0 comma pi is the limits. And again, according to here also, the function is e power minus x into sin x. That means we need to again remember whatever you know that the property, every exponential function is also continuous function, and every exponential function is also derivable functions, and again that sign, that means every trigonometric function is also continuous, and the intervals are 0 comma 2 pi, that is specifically particularly given the limits. Here the limits are 0 comma pi, therefore based upon that 0 comma pi, here the function is the exponential function is a continuous function, and again that the trigonometric function is also continuous in the interval that is a 0 comma pi is the value. That means here, since sin x and e power x both are the continuous function in the 0 comma pi, therefore sin x into e power x is also continuous function in the 0 comma pi. And further, we need to understand. That means in other terminology, at x is equal to 0, for example, just know what I explained like that. For example, for our understanding, at x is equal to 0, the function is e power minus 0 into sin 0. The value is nothing but 0 because of sin 0 is equal to 0. And again, it is e power minus pi into, that is sin pi, that is also 0. There is no term of the infinity. Therefore, the function is clearly it is a continuous function. That is a understanding purpose. And similarly, the function is a second one, it is a derivable. And the derivable is nothing but, for example, it is a e power minus x into sin x. The derivative is nothing but, it is a e power minus x into, that is a cos x. And again, sin x into e power minus x, the derivative is minus 1. Therefore, e power minus x into, that is a cos x. Here, minus e power minus x into sin x is the value. And here also, at x is equal to 0, after the derivative in the second condition, the derivative at x is equal to 0, the first term it should be 0. And here e power minus pi, and again cos pi. The cos pi is equal to value is 1. That means totally the finite value is obtained. And again at x is equal to something pi value, and x is equal to pi. At x is equal to pi is also according to that cos pi or something sin pi. The second term is also something 0. The first term it should be that cos pi is nothing but minus 1. Therefore, and it is also a finite value. That means the derivative is existed, and moreover in the interval in between 0 comma pi the function is also finite value. Therefore that is for understanding purpose. It is a function is a what is that? It is a continuous function in the closed interval, and as well as the function is a derivable function in the open interval a comma b. And based upon this, we need to assume that we need to find out what is f of a and f of b. And just now we clarified that f of a, that is the f of 0 is equal to the value 0, and f of b, that f of pi is also, just now we explained that 0 value after replacement x is equal like that 0 and x is equal to pi. As we know that sin x is sin 0 is 0 and sin pi is also 0. And here the three conditions are satisfied. One is the continuous function, and again the first is a continuous function, and again the derivable function. First one continuous in the closed interval, the derivable in the open interval, and f of a is equal to f of b. And further, the three conditions are satisfied, the Rolle's theorem is satisfied, and further f dash of c is equal to 0. That means according to the u by v, it is e power x, that is u by v, as you know that denominator into numerator derivative minus numerator into denominator derivative by, that is a denominator whole square. That is another formula by using the derivative. And again, after getting that simplification of this one, now we need to equate the 0. F dash of c is equal to 0. That f dash of c is equal to 0 means, that is at x is equal to c means cos c minus sin c by e power c is equal to 0. And again the cross multiply, we obtain that cos c minus sin c is equal to 0. That means cos c is equal to sin c. And cos c sin c is equal to c means tan c is equal to 1 because of the division, that is LHS to right side, that is a tan c is equal to 1. And tan c is equal to 1 means whenever the value is tan c is equal to 1, the tan pi by 4. Therefore, it is a tan pi by 4. It is a tan c is equal to tan pi by 4 means that c is equal to pi by 4 is value. Therefore, that pi by 4 is nothing but it is lies in between the limits are 0 comma y. Therefore, here according to the three conditions are satisfied. That is, one is a continuous function in the closed interval, and second one the derivable in the open interval a comma b, and the third condition f of a is equal to f of b is also satisfied. Then there exists here it is a point is c belongs to a comma b, that is the conditions are satisfied. That means according to the requirement of the Rolle's theorem it is clearly satisfied. Therefore the Rolle's theorem is verified the conditions. These are the one based upon the exponential and trigonometric we need to identify properly. And for example, one other, verify the Rolle's theorem for the function f of x equal cos x in the interval 0 comma 2 pi. That means here also the trigonometric property that is based upon that. Every trigonometric property, every trigonometric function under the cos x is a function is a continuous on the interval of 0 comma 2 pi. Our clarifications, cos 0 is 1, that is cos 0 is 1, and again cos 2 pi is also 1 value. And based upon this one, the both are the like finite value. That is our clarification simply. Therefore, the function is a continuous functions. And again, similarly, here that derivable, second function, the cos x derivative is a minus sin x. That is a minus sin x means again the sin x in between 0 comma 2 pi. For example, that sin 0, the value is 0. Sin 2 pi, that is also 0. By taking any middle of the values, it should be clearly satisfied the final value, that particularly sin value. Therefore, the function is a derivative exists, and moreover in between the values are also the points are the derivable. And again further that f of a, that f of a is nothing but it is a that is a cos 0 is 1, and f of b, that cos 2 pi is also 1. Here nothing but f of a is equal to f of b. The conclusion, and based upon this one, here it is a Rolle's theorem is satisfied. And if it is satisfied means verified means, then we need further that what is the f dash of c is equal to 0. And here f dash of c, that means minus sin c is equal to, that is a something 0, that is a sin c is equal to 0. Therefore that c is equal to, that sin c is equal to 0 means that minus sin c is equal to 0 means sin c is equal to 0. Sin c is equal to 0 means that is a sin 0. Therefore according to here that c is equal to 0 is a particular point. And based upon this particular point, as we know that something in general value also sometimes it is a sin c is equal to sin for all values of like plus or minus n pi is also it is a satisfied, because of it is a sin c is equal to, that is a in general value sin c is nothing but that is a sin, that is a plus or minus, that is n pi. Therefore it is c is equal to plus or minus n pi is the general value, and based upon this one n is equal to 1 and n is equal to 2 is also something 0, and again that pi and also 2 pi. Therefore it is also in other terminology we need to assume that it is also pi is also that lies in between the given interval of the under that 0 comma 2 pi. Therefore based upon this one here, that is the meaning of here according to how to get means, that is for understanding purpose, that is the meaning of that is a c is equal to pi, that is based upon the general value, it is 0 to 2 pi, in between the value it is a satisfied. Therefore verified the Rolle's theorem. One is a continuous in the closed interval and the derivable open interval a comma b, and f of a is equal to f of b, then there exists here c belongs to a comma b such that f dash of c is equal to 0. Therefore conclusion of this one, the Rolle's theorem it should be verified the conditions. And further, for example, here verify the Rolle's theorem, it is also like that easy to understand, that is based upon the exponential and polynomial function. Here first one is multiplied with x into x plus 3 is nothing but x square plus that is after that consider x square plus 3x into e power of minus x by 2. This is somewhat according to that exponential, and again it is a polynomial function, it is also continuous function. In other terminology, our clarification, it is by taking the replacement of minus 3 comma 0, it is automatically the numerator value only, therefore it is a finite value. Therefore continuous function is a continuous function, and derivable means here the derivative is also existed, that is x square plus 3x into that is a e power of minus x by 2 into derivative of is nothing but minus 1 by 2 plus e power of minus x by 2 into that is 2x plus 3. Here the derivative is also existed, then at this in between the points are minus 3 comma 0, there is no infinite value, therefore the function is also derivative is existed. For example, f of a, f of a is equal to clearly that in the given point that x is equal to minus 3 value is 0, and again the b point at x is equal to 0, the value is also 0, therefore f of a is equal to f of b is a condition. Therefore either the three conditions are satisfied, then the Rolle's theorem is also okay. Then further f dash of c is equal to 0, then there exists c belongs to a comma b. That means f dash of c, that f dash of c is nothing but just now I assume that according to that is a product rule, that is u into v dash plus v into u dash, and again after this one we need to replace x is equal to c, therefore the value is here after replacement of x is equal to c, and again take out common 1 by 20 power of minus 1 minus c by 2 is a common, the remaining part is this one. And again here by equating the 0 means that is a c square minus c minus 6 is equal to 0. By solving this one we obtain that minus 2 comma 3 is the value. And while we are going to observe here, the problem is minus 3 comma 0. That minus 3 comma 0 is nothing but the one of the value is nothing but minus 3 and minus 2 minus 1 and again 0 and again 1 and again these are the values. Up to here these are the values. In between the values are minus 3 comma 0 based upon this one. Here the one of the values lies in between, that is a minus 2 comma 3. The other 3 is a not satisfied, but it is a c is equal to minus 2 is satisfied. Therefore the conclusion, the problem is satisfied at c is equal, that is a minus 2 only, that lies in between the minus 3 comma 0. Therefore verified the Rolle's theorem. One is a continuous satisfied the closed interval, and the derivable is satisfied in the open interval, and f of a is equal to f of b, and moreover f dash of c belongs to a comma b, c belongs to a comma b is satisfied. Then the Rolle's theorem is verified the conditions. That is the meaning of, according to these are the clear explanation, we need to understand how to verify what are the conditions for the Rolle's theorem is satisfied. And similarly, for example, it is also the problem is based upon the f of x equal log of this one. Here for clarification purpose again, that log of a by b, we need to further according to log a minus log b. Here according to every logarithmic function is also like the polynomial function, it is a continuous function in the particularly the given interval closed interval a comma b, because of it is also there is no infinite value, because of it is not like that 1 by n is a formula like 1 by x. It is clearly based upon log of this one and log of x1. For all values of x is equal like any positive values, it is a like it is a function is a finite value only. There is no particular value it is equal to infinity. Therefore, it is a continuous function. And again, that's a derivable. The derivable is nothing but according to log of x is nothing but that is a 2x by x square plus ab minus log x is nothing but it is a 1 by x. That means it is a derivable, and it is also derivative is existed, and it is also clearly understood that is a particular point it is equal to it is a derivable function, and f of a is equal to f of b means at x is equal to a, the first term and again the together the second term it is 0, and again that b is also 0, and here the conclusion, first condition existed, second condition existed, third condition existed, and based upon these three, then further it is a Rolle's theorem is verified. And finally we need to find out what is the C belongs to A comma B, is it satisfied or not, and clarification, f dash of C is equal to 0. That f dash of C is equal to 0 means here whatever you know that the function f of x, we need to find out here f dash of x. That f dash of x is nothing but according to it is a like 1 by x square plus ab minus 1 by x, that is into 2x, the derivative of this one, the first log of x square plus ab, and again the second function that is a f of log x derivative, and it is equal to, after take the LCM and again simplify, you obtain that x square minus ab by x into x square plus ab after take the LCM, and here f dash of c is equal to 0. That means again we need to replace in the x is equal to c. That means numerator part equate the 0. That means c square minus ab is equal to 0. That is f dash of c is equal to 0. And while we are equating this one, again c is equal to the value is under root of ab. That's square root of ab. That means square root of ab is nothing but for any value it should be that is a belongs to a comma b. By taking any values of the finite or infinite, you get that clearly it is a square root of ab is nothing but it is lies in between a comma b. Therefore, the Rolle's theorem is verified based upon the like continuous function in the open interval a, closed interval a comma b, and the derivable open interval a comma b, and f of a is equal to f of b. Then there exists c belongs to here a comma b is satisfied. Therefore, Rolle's theorem is verified the conditions. These are the some problems like trigonometric and exponential and logarithmic and also the polynomial and product of the two, that all the problems together based upon these are the functions are the continuous function. For example, here also same like that. While we are going to observe here, for any values it is a finite value, it is a continuous, and derivative is also the particular value is a continuous function. Like derivable function, it is a existed. There is no particular value of that infinitive values. And f of b equal to f of b. Thus all the conditions are satisfied. And here also. And sin is equal to 0 means here also based upon that sin is equal to 0 means for all values of sin of that plus or minus n pi in general value, therefore c is equal to plus or minus n pi. Here n is equal to like pi, 2 pi, 3 pi, 4 pi, like that. Here according to that pi and 2 pi and 3 pi and again 4 pi. These are the in between the values. Here 4 pi is like according to the given problem, that is a pi by 4 and 2 pi by 4 and again 3 pi by 4, 4 pi by 4, and it is nothing but in that observation, that is the last one is a pi value. That pi is nothing but it is clearly satisfied the pi value. That means according to one of the values c is equal to 0 or pi, the pi is lies in between pi by 4 comma 5 by 4. Therefore, conclusion of this one, it is verified the Rolle's theorem based upon the conclusion of continuous in the closed and derivable in the open interval, and f of a is equal to f of b, and then there exists c belongs to a comma b such that it is a c belongs to a comma b. Therefore, the verified the Rolle's theorem of the conditions. For example, these are some different type of the problems. Whenever the functions are the continuous or not, here up to what we discussed, that is a continuous function, it is clearly satisfied. And further, we need to discuss when the function is not a continuous. That also we need to understand. That based upon just now, after that understanding of all these things, here verify the Rolle's theorem. It can be applied for the following functions or intervals. That means we need to verify that f of x equal to tan x, is it 0 comma pi is a continuous function? First of all, the Rolle's theorem, continuous function, that means sine, for example, closed interval, sine 0 like tan 0, that is 0, tan pi, that is also 0, and again other values by taking any values, that also clearly function is a continuous functions. Sorry, not it is x is equal to something, it is 0 comma pi. That x is equal to 0 comma pi, the values are 0 comma pi by 2, and again pi by 3, and pi by 4, and again pi by 6, and pi by 8. Here, by taking all these values, first one is like 0, second one is also 0, and pi by 4 is also something one value, and other values are also maybe it is applicable. But x is equal to pi by 2. The tan pi by 2 is not a like what is the tan pi by 2? That is a 1 by 0. That 1 by 0 is nothing but it is infinite value. Therefore, the function is at x equal to pi by 2 in the value of the middle value according to the closed interval, that including the first and last, and in between the values are also we need to check it. Here the first and last is okay, and middle of the one is also some values are also it is okay. But while we are going to observing here at x equal pi by 2, the value is a infinity value. That means according to based upon the general concept, what we understood here, the function is a not a finite value. It is a like it is an infinite value. The function is nothing but it is a discontinuous function. Therefore, at x equal 0, the x equal pi by 2, the function is a discontinuous function. Therefore, first condition itself it is not existed. Therefore, we should not go to check that is the second and third and also that finding that f dash of c is not required. Therefore, the conclusion of this one, the f of x is equal that is a tan x under the interval of 0, pi, the function is not a satisfied the Rolle's theorem. We cannot apply for the Rolle's theorem because of x equal pi by 2 it is a not defined. Because of it is at x equal pi by 2 not defined means it is at x equal to pi by 2 the value is a infinite value. Yeah, these are the three conditions. For example, this one. For example, it is also we need to check whether the function is a Rolle's theorem is applicable or not. That means x is equal to f of x equal to x cube. Here 1 comma 1 3 means 1 comma 2 comma 3. At 1 is equal to x is equal to 1, the value is finite, and x is equal to 3, the value is finite. In between any values, the value should be finite value. Here the value is not important that it is a finite or not. Therefore, the value it should be it is a finite value. Therefore, the function is based upon the function f of x is a continuous function in the closed interval a comma b. And for example, it is a second condition. The second condition, f dash of x. That f dash of x is nothing but it is a function is it is a 3x square in the open interval 1 comma 3. That means it is satisfied only 2 is a value. At x is equal to the function is in the place that is a finite value. Therefore, at x is equal to 2, the function is also finite value. Here also the value is not important. Is it finite or infinite? Therefore, it is also a finite value. Therefore, the function is a derivative is existed, and moreover that particularly in the open interval that also finite value. Therefore, it is a derivative is also existed. That is the second condition is also it is applicable. And further, we need to check that what is a f of a and what is a f of b. And f of a is nothing but the value at x is equal to like 1, the value is 1, and f of b, and here f of a is nothing but it is a f of 1 is nothing but it is a 1 cube is nothing but 1, and f of b it is nothing but it is a 27. And based upon this third condition, it is not equal to the conditions. Therefore, f of a is not equal to f of b. Based upon these are the not satisfied the same values. And here the conclusion, first condition is satisfied, the second condition is satisfied, and again based upon the third condition itself, it is not satisfied. Therefore, the Rolle's theorem itself, it is not applicable for this f of x is equal to x cube in the interval that is 1 comma 3 is the conditions. These are the some clarification to find out. The three conditions are satisfied, then only we need to find out. Whereas in the first problem, like before this problem, that is the first condition itself not satisfied. These are the continuous okay, derivable okay, but f of a is not equal to f of b. Therefore, condition of the three conditions, it is not satisfied the three conditions. For example, this one. While we are going to observing here also, the function is 1 by x square. 1 by x square. The limits are minus 1 comma 1. As per our Rolle's theorem, it is minus 1 comma 1 is nothing but minus 1 including, 1 including, and middle of the value is 0 is the value. Here, minus 1, the function is as per the checking of the continuous in the closed, minus 1, the value is that is 1 by minus 1 whole square is nothing but 1 only. And 1 by 1 square is nothing but it is also 1. That means it is a finite value and it is also finite value. And moreover, in the middle of the value at x is equal to 0, at x is equal to 0, the value is 1 by 0 square is nothing but infinity. That means it is not a finite value. Therefore, the function itself, it is the first condition does not hold because of at f of x is the function, it is not a continuous function, it is under the limits are like minus 1 comma 1. That means at x is equal to 0, the point is a discontinuous function. Therefore, it is also based upon that the function itself, the first condition itself, it is not satisfied the Rolle's theorem. Therefore, we are not going to further that verification the second and third conditions. Yeah, these are the some clear informations. Like, for example, this here also that x power of 2 by 3 comma minus 1 comma 1. Here according to that function is a minus 1 comma 1. One of the value is 0. That means at x is equal, for example, minus 1. It is a numerator. Numerator is nothing but automatically finite value minus 1. And again 1 value. Therefore, it is also a finite value because of 1 power of 2 by 3 is also a finite value. That means at x equal to minus 1 it is finite and x equal to 1 it is also finite value. But x equal to 0 it is also 0 power of 2 by 3. That means it is also finite value. That means f of x is a continuous function under the interval of that is a minus 1 comma 1. And what is the, that means the first condition itself it is a satisfied. The derivative, for example, what is the derivative? That is f dash of x is nothing but that is 2 by 3 into x power of 2 by 3 minus 1 is nothing but 2 by 3 x power of minus 1 by 3. It is nothing but 2 by 3 into 1 by x power of 1 by 3. The denominator, that means here the limits are minus 1 comma 0. Therefore, it is between the value is 0. Therefore, at x is equal to 0, what is it? The value is nothing but 2 by 3 into 1 by 0. The value is nothing but infinity. That means here the continuous function is satisfied in the closed interval minus 1 comma 1, but after the derivative it should be applying at x is equal to 0. The value is not a finite value, it is a discontinuous value because of at x is equal to 0, the value f dash of x, that particular function is a infinite value. It is a function is a not a continuous, it is a discontinuous at x is equal to 0 is the point only. And again, therefore, the third condition it is not required to find out. Then based upon this one, we need further finding. It is not required. Here, hence the Rolle's theorem it is not satisfied because of it is a function is a discontinuous function at x is equal to 0. It is not defined the value. Yeah, these are the particular values we need to identify whenever the function is a continuous function, whenever the function is a discontinuous functions. Yeah, like this. For example, the second conditions. What is the second condition? That is the second type, second method, Lagrange's theorem. The Lagrange's theorem is also, here the conditions are equal to satisfy. What are the conditions to satisfy the Lagrange's? That means, whenever the function is such that, f of x b is such that, here continuous in the closed interval a comma b, same like in the previous concept. The derivative is also open interval, that also the same conditions. But the third condition, it is G, then there exists C belongs to A comma B such that f of B minus f of A by B minus A is equal to f dash of C. That means comparison to the first condition, the third condition it is not required. Based upon the first and second condition, it is required satisfied. Then there exists C belongs to A comma B such that f dash of C is equal to f of B minus f of A by B minus A is the conditions. If the three conditions are satisfied, then only the Lagrange theorem it will be applicable. Yeah. It is a continuous in the closed interval and the derivative open interval a comma b. Then there exists C belongs to A comma B such that f dash of C is equal to f of B minus f of A is the conditions. B minus A is equal to f dash of C is the conditions. Yeah. In the geometrical is same like that, same as this. While we are going to observing here f of A is not equal to f of B because of here it is f of A and f of B, it is a not distance from the A to B. Therefore, it is a difference between the conditions clearly while we are going to observe. It is a same the distance, it is a not satisfied because of it is a not a same conditions. Based upon this one, it is a not a f of A is equal to not equal to like f of A. Continuous open interval like this. The rest of the thing is same. Further, we need to discuss some problems. Verify the Lagrange's mean value theorem for the function f of x is equal to, the problem is like this. And here also based upon the continuous function, we clearly understood at 0, the value is that f of x is as per our formula, like same property. every polynomial function is also continuous function, and every polynomial function is also derivable under the closed and also open interval. It is clearly satisfied. In other terminology, the first value at x is equal to 0, the value is numerator, it is a positive value, any values. And again, x is equal to b, that is the function is also finite value, therefore it is also continuous function, and based upon that, the function is a continuous function. In other terminology, it is a polynomial function is also continuous. And derivable. The derivable is nothing but 3x square minus 2x minus 5. That is the meaning of 3x square minus 2x minus 5. It is also like a numerator, it is a polynomial function. Therefore, it is also derivative existed. In between the values are 0, 4. All the values, it is a finite value. Therefore, derivative is also existed. And here the two conditions are satisfied. That means the Lagrange theorem is satisfied. And further, f dash of c is equal to f of b minus f of a by b minus a. And here, what is first we need to find out what is f of a. That f of a is nothing but here this is the f dash of c is the like 3c square minus 2c minus 5. And here f of a derivative existed clearly. And here f of 4 is the value is 31, and f of 0 is 3 value, and f of b minus f of a is the value is after the replacement here. C is equal to. And here after that simplification, this one, while we are going to observe here, further it is C is equal to plus or minus 148 by 6. That means the conclusion it is also one positive, one is a negative. And again, based upon that it is a negative, it is not required because of as per the given function, it is not required to satisfy in the given interval. Only the positive value it is clearly satisfied. That too, here C is equal to, it is 1 plus root 37 by 3 is a lies in the open interval a comma b, that is a 0 comma 1. Because of at 1 minus root of 37 by 3, the value is 1 minus, that is 6 point something by 3. Therefore, it is 1 minus 6.3 is nothing but it is a minus 5 point something by it is 3. Therefore, it is a minus 1 point something like that. Therefore, it is minus 1 point something is not at all lies in between the given interval 0 comma 4. Therefore, it is only the positive value. It is a positive value only. It is lies in between a comma b. That is 1 plus root 37 by that is a 3 is the value. Because of 1 plus root 37 by 3 is nothing but 1 plus 6 point something by 3 is nothing but 1 plus 7 point something. That means here the value is a 2 point something like that. The 2 point something is nothing but automatically lies in between. These are the values. Hence the rule Lagrange theorem is satisfied. Further, here also while we are going to observe here, the polynomial function, it is a numerator, it is a like a continuous function. There is no particular value at x equal to 0 or something, for it is a not a infinity value, therefore it is a continuous function. And other terminology, it is every polynomial function is also continuous function in the open interval closed interval 0 comma 4. And the derivative, we need to find out the derivative. That means x into x minus 2 into x minus 3 is nothing but the derivative is nothing but it is a here x square 3x square minus 10x plus 6. Because of here x into x minus 3 is nothing but x square minus 2x into that is x minus 3. And again after that derivative you obtain these are the values. And again here f dash of c, that is a 3c square minus 10c plus 6. And further we need to find out what is the f of b minus f of a by a. Here a is nothing but 0 and b is nothing but 4. Two conditions are existed, third condition is existed. Here the value is nothing but we can identify this one, easy to understand. But in other some different type of problems we are going facing problems. And here also 10 plus root 15 by 2. That means it is also 10 plus 1 is 52 means it is 7 point something by 6. It is also 17 point something by 6. Therefore, it is also 2 point something like that. Therefore, it is also the positive lies in between the values is see it is actually the negative value is also it is applicable that based upon the given interval 0 comma 4. I think 0 comma that's minus means for example it is a minus means that is a 7 minus 7 point something by 6, it is nothing but 3 point something by 6. Therefore that point something 0.5 something, therefore that 0.5 something is also it is lies in between the inside of the given point, that is a C limits. Therefore the three conditions are satisfied, it is satisfied the conditions. And log x agrees logarithmic function is a continuous functions applicable here. Three conditions. The three conditions are satisfied. And similarly, like this is some different type of the problem while we are going to observe here. Continuous function, derivable functions. Yeah. Here, according to the when we are going to find out this one, f dash of c equal 1 by 1 plus c square. Here we need to remember this is very important to understand. It is a then the exists c belongs to a comma b is nothing but a is less than c is less than b is a condition. But we need to equate what is the 1 by 1 plus c square. For that we need to modify it. That is a condition. 1 by 1 plus c square. Automatically according to the reciprocal is also there is no changes. Only the signs will be changed. Here 1 by 1 plus c square is nothing but as you know that the value of tan must b minus tan must a by that is a b minus a. Again we need to like this is actually the required solution of once it is a result is there. And based upon this one we need to further the two verifications. One is the conditions. By replacement of forward values it is a deduction the conditions. Taking the b is equal to 4 by 3 and a is equal to 1 by 7. And again further other value also b is equal to and a is equal to 1. Therefore, these are the particular values. That means it is a for the purpose of this one we obtain that by taking the b is equal to 4 by 3 1. And again that second one b is equal to and a is equal to 1 we obtain the required solutions. And similarly here also if you want to verify this one, first of all we need to know that what is the derivative of sin inverse x. The derivative of sin inverse x is nothing but here based upon 1 by that is 1 by root of 1 minus x square. And one more we need to remember what is the Lagrange's. It is the f dash of c is equal to f of b minus f of a by b minus c. These two conditions we need to require. And again then there is c belongs to a comma b. And again here further we need to find out modification that is up to here. That is a is less than c is less than b. And from here we need to reduce 1 by root of 1 by c square. For that we need to again modifications are required. Yeah, like this. This is a very important to understand. Then there exists sequence state of B. Then only it is a problem is easy to understand and easy to verify the conditions. That means we need to understand that C2 how to get that 1 by 1 by 1 C square. That is first is a squaring and subtraction and again square apply the under root and again further here by using that 1 by 1 minus this one you can replace here. This is the value. And again after that again we need to understand after that how to reduce the problem. That means by taking that d c is equal to b is equal to 3 by 5 and a is equal to 1. Sin inverse of 1 by 2. As you know that sin inverse of 1 by 2 is nothing but sin pi by 6. Because of sin inverse of sin theta, that means sin inverse of sin pi by 6. Then that is theta is nothing but here pi by 6. That means sin pi by 6. Sin pi by 6. Sin inverse of sin theta is nothing but theta. The theta only you can replace. Here it is a pi by 6 and it is also right side is also pi by 6. Yeah, like this. And again here also we need to remember what is the formula for cos inverse x. As you know that the cos inverse x is nothing but minus 1 by root of 1 minus x square. And if you know that this one, then only it is a survey of the problem. And moreover, the Lagrange's formula is also we need to understand. And again here, from here C2, how to get this is the minus 1 by root of 1 minus x square. That means squaring and subtraction and again that square root of with 1 minus and again division with minus 1, then find the solutions. Like that. And cross multiply with minus b minus a And again here, reduce means again b is equal to 3 by 5 and a is equal to 1 by 2. Again we need to understand what is the cos inverse of like 1 by 2. The cos inverse of 1 by 2 is nothing but cos inverse of, it is a cos pi by 3. And cos inverse of cos theta is nothing but theta. Therefore, that pi by 3 is nothing but it is a pi by 3 and here, and it is also pi by 3. These are some different type of problems occurring under the Lagrange mean value. And here also that x is greater than 0 is given. That means 0 comma x is the considered the closed interval. Like different problems. Here it is also easy to obtain e power 0. And this is the required solution after that applying that cross multiplication and again the additions. Further, what is the Cauchy's mean value theorem? These are the last theorem under the mean value theorem, the Cauchy's theorem. And especially under the Cauchy's mean value theorem occurring like the two functions. One is f of x and second one is g of x. That is the meaning of if f is a function in the interval a comma b to real number and g is a function a comma b to the real number, then there exists such that f comma g both are the continuous in the a comma b closed interval and f comma b is both are the derivable in the open interval a comma b. Then there exists c belongs to such that it is a f dash of c by g dash of c is equal to f of b minus f of a by g of b minus g of a. It is a condition. Provided here g dash of x is not equal to 0. If it is g dash of x is equal to 0, for example, the value should be it is infinite. Therefore, due to that reason, we should be clearly that is not equal to 0 is satisfied. That is a continuous derivable provided and f dash of c by g dash of c is equal to f of b minus f of a by g of b minus g of a. Then there is c belongs to a condition. For example, here the problem is clearly showing that two functions, that means under the Cauchy's mean value theorem however. Therefore, here both are the polynomial functions under the closed interval. There is no particular value at a is equal to any value that is an infinite value. Therefore, continuous functions. And derivative also existed, derivable existed. And here the conditions here. That means here A is the one given point and B is equal to 2 is a point. Therefore, f dash of c. This is simple. That is f dash of x is nothing but that is 4x cube, and again g dash of x is nothing but 2x, and again therefore the function is nothing but 4x cube, 4c cube, 2x, 2c, and here 2 power 4 minus 1 power 4. Here the value is c is equal to plus of root of 4. That means the value is nothing but 1 is the value is 1 comma 2 is less. Here it is a negative value, it is not applicable because of under the limits are given like 1 comma 2 only the particular positive values are given. Therefore, at this condition, the value only it is a positive value, that is a root of 5 by 2 is a lies in between 1 comma 2 is a value. Cauchy's mean value. Similarly, like any problem is given, it is also exponential normal conditions. Because of exponential function under the real positive values. Here f dash of c, that means e power x derivative is a e power c derivative is a e power ac, and e power c is also nothing but e power c. And g dash of c x is nothing but that is minus e power minus x. That derivative of g dash of c is equal to minus e power of minus c. And second one, the g dash of x is a minus e power minus x, and it is a minus e power minus c. And with the help of this one, including the f of b minus f of a by g of b minus g of a, while we are going to replace here, we need to understand here e power c into e power of that comes to numerator, that is e power c into e power c into e power of that is c, that is e power of 2c is the value that is let's say. And again the right side it should be right according to these are the derivative. And now here take the LCM. Here like according to e power a and e power b, take out common LCM, and again e power a minus e power b. And after that, again left side is no problem and right side is e power of that. After take the denominator negative, that should be cancelled. And again e power a and e power b is the e power of a by b here. And sometimes this is indirectly the problem is based upon a plus b beta. That is the meaning of algebra arithmetic mean conditions. A plus b beta is also indirectly arithmetic the functions. the functions satisfied, continuous, differentiable. And here we need to understand what is root x, that is a 1 by 2 root x, 1 by root 2c. And what is a g dash, g of x, that means 1 by root x. The derivative of minus 1 by 2x into root x, because of 1 by root x, the derivative is nothing but minus 1 by 2x into root x. That is the derivative of this one only you can find that. And g dash of c is nothing but minus 1 by 2c root c. And here root of a means it is the meaning of geometric mean. In other terminology, it is the meaning of geometric mean from the given problem. Sometimes they are asking to show that is a functions are satisfied in the geometric mean, means we need to understand the geometric mean is nothing but the root of AB. And in case of the A plus B is nothing but that is the arithmetical mean. Yeah, that is the meaning of the by taking any values. Like here f of x is nothing but minus 1 by f of x equal 1 by x square, and f dash of x is nothing but minus 2 by x cube, because of x power of minus 2 is nothing but minus 2 into x power of minus 2 minus 1, it is minus 2 by x cube is a value, that only you can replace minus 2 by x cube. And g dash g of x, that means minus 1 by x square. And again, as we know that according to by using the formulas, we can replace, find the simplification after that. Here, this is the meaning of harmonic conditions. HP line. Sometimes it is also indirectly. Yeah, it is the last problem under this is the Cauchy's main value theorem. While we are going to observe here, it is a different terminology. It is given arctan. Arctan is nothing but it is a meaning of, without any misunderstanding, it is a tan inverse x. If we understand the tan inverse x, automatically the function is a, how to verify what is the derivative. Tan inverse x is nothing but that is a 1 by 1 plus x square. Yeah. This is the last problem under this is the mean value theorem, under the final, that is a Cauchy's mean value theorem. Yeah, this is the meaning of arctan, means that is a tan inverse x. We need to observe that. And from the equation 1, whatever we know that is the condition of this one. Given the intervals are certain, particularly 1, 0, 1. See, it is a c is equal to, after that simplification of this one, you may get that is a plus of like root of values. And anyhow, it is automatically that plus value will lies in between 0, 1. We should not consider any negative, because of that under the 0, 1 it is a negative value, it is not required. Only we need to consider that is the positive values of c values. Therefore, hence verified the Cauchy's mean value theorem. Why? Because based upon all the conditions are it is satisfied. One is two functions are continuous, and again two functions are derivable under the closed and also the open interval. Continuous and the closed interval and open interval is like a derivable. And again, then there exists c belongs to a comma b such that f dash of c by g dash of c is equal to f of b minus f of a by g of b minus g of a is the conditions. These are the three theorems under the mean value theorem we discussed clearly. I hope everybody understood that these are the mean value theorem based upon the rules of Lagrange's and Cauchy's mean value theorem. If any further information is required, please give the reply under the link only. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.